Could you calculate the speed of light by using your daily kitchen appliance, a microwave? Well, yeah. Let's figure the science behind it first. Basically, microwaves are a part of the electromagnetic radiation which sit right between infrared waves and radio waves. They are produced by a device called magnetron and leave from the hole in the right. They are reflected back and forth from the two sides of the oven. The wavelength of microwaves is tuned to produce a standing wave, which is formed by two waves having an opposite phase, that is, moving in opposite direction with respect to each other. They interact with each other to make some areas where there are huge oscillations and other where there are none. Thus, there are places where the microwaves are very intense, where molecules vibrate very powerfully and are heated strongly, others where the microwaves are weak. The heat intense areas are separated by half of the wavelength, since wavelength is defined as the distance between two successive crests or troughs. That's why there is a rotating tray so that the food is prevented from being unevenly heated. The fascinating part about electromagnetic radiation is that they travel at the speed of light. A handy equation to connect the frequency, which is the number of times the oscillations repeat themselves with the wavelength with the speed of light, is speed of light c is given by wavelength into frequency. Finding the frequency is an easy part. It's listed in the label of the company. For our experiment, it's 2450 megahertz, which is 2,450,000,000 hertz. Finding the wavelength, we use the fact that the heat intense areas are separated by a distance of half of the wavelength. Now, first of all, take out the rotating tray from the microwave. Now, place some chocolate on a little tray and heat it for low heat. Now, take the chocolate out. Now, measure the distance between the melted spots. In our experiment, we find it to be 6.3 to 6.4 cm, which implies the wavelength is approximately 12.6 centimeters. Substituting it back in our handy equation, the speed of light is 2450 megahertz into 12.6 centimeter, which is approximately close to the actual speed of light, which is approximately 300 million meter per second, or to be precise, 299,792,458 meter per second. There you go, you have the speed of light from your microwave. Thank you.